Hello everybody, hello my students, hello my followers and people who love math and want to be better in math. In today's video, as the title says, I'm going to show you how to solve the absolute value equations. And basically you will see that there are two ways how you can solve the absolute value equations. The first procedure or the first technique you can take is to solve the equation graphically. Or the second procedure or method you can take is to solve the equation algebraically. Okay, so to explain everything, the best idea is to start with very easy equation, which is, for example, absolute value of x is equal 3. Yeah, I know that you already know the solution, that x is equal to 3 or is equal to -3, but I want to explain you why and how does it work, and so that you can use this procedure also for a little bit more complicated absolute value equations. So let me start first with the explanation. As we want to solve the equation graphically first, we have to understand what is behind this equation, and basically the main idea when you are solving and the idea is like general, when you are solving any equation, the main thing is that the expression which is on the left side of the equation is basically and technically representing any function which equation or definition is in our, like the first case, in our situation or in our equation, our function is defined by the equation y equals absolute value of x, and then the right side of the equation is also representing any kind of function. In this case, let's call it g of x, or the function g is defined by the equation y equals 3, which is constant function. So basically, when we are solving any equation, it means we are trying to find and answer the question, when does the graph of function f, and the equal sign is representing, or it continues our sentence, when does the graph of the function f intersect the function g or the graph of the function g, which in this case the sentence can be said like this in our equation: when does the graph of function f intersect this value. Okay, if it's really like constant, you can say we are looking for the intersects of these two functions, f and g. In this case, g is constant function, so when does the graph of function f is equal to this value, so number 3 in this case. Basically, if you have a look on these definitions of our functions, what I have written here, you can find out that these functions are equals if and only if y of f is equal to y of g, which basically, or you won't see this quite often, but I just had to put the indexes there so that you'll understand that this is not the same y's, though the values will be the same. So if you rewrite this equation instead of using y's, you will get our equation. Okay, so the absolute value is equal to absolute value of x is equal to 3. So now this is the theory behind this. Let's have a look what it means in a graphical way. So we have to sketch the graph of our function f, which we already know. The graph looks something like this. And it is very important, if you sketch or solve the equation graphically, the most important thing is you sketch the graphs or draw the graphs really like very precisely. So you should be using the ruler and really, let's say, sharp pencil. Okay, so just let me sketch a couple of points here so that we really can see. And this is our function y equals absolute value of x. Now let's sketch the graph of the second function. Let me just do it a little bit. Oh, okay, it's okay, like in black. So now we look for the graph of the function y equals 3, which we already know is the constant function. And if we have here the number 3, y equals 3, so this graph is represented by the straight line. And basically this straight line is y equals 3 parallel with our x-axis. And as you can see, I will finally do it like in color. As you can see, these two graphs are intercepting each other in 2 points, and the points where the intercepts are these 2 points. So this is basically graphically answer to our question, when is this happening, for which x. And if we would sketch the graphs like really precisely, we will find out that the numbers are -3 and 3. Yeah, as you can see, this is just sketch. That's why it doesn't fit like really properly, but if you would do it properly, then you will be able to see that this is our solution. Now let's have a look. So this was the solution like graphically. So let's have a look now, how do we solve this equation algebraically. As we already know, and as I said a lot of times, the absolute value of x algebraically is defined that it is equal to x if and only if x is greater or equal 0, or it is equal to -x if and only if x is less than 0. So what does it mean for us? It means that our equation absolute value of x is equal to 3 will now be defined for each x from the interval of 0 to the infinity, which comes from this condition. And then this equation, it means that our equation is defined then like x is equal to 3. So this is our first solution. Okay, the second one is like for x being from the interval the negative infinity to 0, which then would mean that -x is equal to 3, which is of course if and only if x is equal to -3. So this is our next solution, and as you can see, algebraically we really found the same results as we did graphically. There is one more thing I want to explain or just repeat for you. So basically we were sketching the graphs of the absolute value functions, and we were representing for x being greater than 0 the graph with this line, which basically is really the function or the graph of the function y equals x. Okay, and the same applies for x being from the negative numbers, and the representation of our line or the graph of the function y equals -x is this one. Okay, So this is how we solve this equation graphically and algebraically. And there is one more thing I want to stress or tell. How do we read this equation, like in technical way or technical point of view? And we can say that the distance from 0 is 3, which technically means that this is if and only if x is equal to 3 or x is equal to -3, because if you sketch the number line and here is my number 0, then I travel, let's say, like 3 units to the right, 1, 2, 3 units to the right, I will end up on number 3. And if I do the same thing, because the distance is a positive number, I'll travel like backwards 3 units, 1, 2, and 3. My last stop will be at the point -3. Okay, so here is my number 0, and the distance from 0 is 3, even if I go 3 units to the right, or I can go 3 units to the left. So I can see the results also, and I can represent this simple absolute value equation this way. Okay, so this one was really very easy. Let's have a look on, let's say, a little bit more complex example. But first of all, I need to delete all this so that I can use my screen again. And yeah, I will leave this, and okay, we don't need this anymore. So let's have a look on more complex but still very easy equation, which is x take away 2 in absolute value is equal to 4. I'm pretty sure a lot of you can already tell me what the results, because there are 2 results, are. But let's have a look again on the solution graphically. As we said, each equation can be represented in general like this. Okay, so let's have a look what is our f of x function definition. And yeah, you are right, the definition of our f of x is absolute value of x take away 2, and the representation of our function g is g of x is again represented as a constant function which value is number 4. Now it's really like very easy. You again sketch the graph. This time I'm gonna use like proper coordinates and the dimensions. We already know how to sketch the graph of this, because this is kind of transformation or translation if you want to, and it says that you take the parent function, which is this one, and you move it 2 units to the right. So 1, 2, 3, 4, 5, 6. I will definitely need these numbers, that's why I will put them here. So this is my number 2. Vertex of this function is with the coordinates 2 and 0, and as we already know, this will pass through also point 0, 2, which is the intercept with the y-axis. So let's sketch the graph of our first function f, which looks something like this, and this is my f of x equals to absolute value x take away 2. Now it's very easy, we can sketch the graph of g of x, which will pass through the point 4, which is approximately here. And the graph of our function is like this. Okay, I don't like this, but okay, let's do it again, which is graph like this. And how do we know? Because if we put any axis instead of x, which is not definitely here, you will get always the y coordinate 4. So any point on this line, which is by the way again parallel with the x-axis, and it represents the line with the definition y equals 4, is our graph. And as you can see, there are 2 intercepts, and if we draw it like really precisely, we will find out that this is my solution and this is my solution. And as you can see, this is -2, and this number is number 6. Okay, so we have the solution. graphically, so maybe it's good enough to write that the set of the solution is two element set with numbers -2 and 6. So this is our solution graphically. Let's have a look on the solution algebraically. And again, as you were taught and you already know, we have to find out how to represent the absolute value of this expression, and it is equal to x take away 2 if and only if x is greater or equal to 2. Why is it so? Let me just remind you. This is because x minus 2 must be greater or equal to 0, which means x is greater or equal to 2. And basically you already know, when we were sketching the graphs of absolute value functions or piecewise functions, then you know that x minus 2 must be equal to 0 is our key point, or if you want to, our 0 point. So the condition is x is greater or equal to 2, and this expression or the absolute value can be calculated if x is less than 2 by the expression negative x plus 2, which is the opposite expression of x take away 2. Now, if you have a look on this one, it would mean that our equation absolute value x take away 2 is equal to 4 can be calculated algebraically for each x from the interval. And it is like a really easy thing, because all this information you are reading from this line, okay? So if x is from the interval 2 to the infinity, then our equation is represented by this expression or equation if you want to, and it means x is equal to 6. So this is our first solution for this interval, and the second solution comes from the second interval. Later on I will explain you that you really have to think about one important thing, because not always this can be the solution of our equation. And meantime, maybe you can think what is important to keep in mind if you really say that this is the solution without doing the check. Okay, of course the check is the most strong instrument to find out if your solution is correct. So the next representation is for x being from the interval negative infinity to 2, and the equation is then represented by where do I have it? Here. Okay, again I'm reading this information from this path, which means take away x or negative minus x plus 2 is equal to 4, which means negative x is equal to 2, so x is equal to negative 2. This is my second solution for this, for x being from this interval. And if you really think about it and you compare it with the graphical solution, we are again on the same or we did get again the same result. So these both methods are like equivalent. You can use any of them, but when you are using the graphical method, you really have to sketch the graphs precisely to find the exact solutions. Now, as we did the conclusion during our previous example, this equation x take away 2 is equal to 4 can be like again translated or calculated when you think about it technically, which means, and it says basically that the distance, because any absolute value represents the distance, but in this case the distance from, and now you just think from which number. If you said from 2, you are right. From 2 is 4, which means, and it is if and only if x is equal to 6 or x is equal to negative 2. And again, if you try to sketch the number line and represent your like sentence or fact graphically on the number line, it really is like this, that here is number 2 and you are looking for the numbers whose distance or what distance are equal to 4, so you travel like 4 units to the right but as well to the left, because the distance is always positive number. So 1, 2, 3, 4, and then you come to number 6, and the same way to the left, 1, 2, 3, 4, and you will come, as here is number 0, you will come to negative 2. So again, you travel from number 2 4 units to the right or 4 units to the left, because the distance must be equal to 4. And if you do so, you will find again the solution of this very easy absolute value equation. Okay? Now let me just do one more simple example, but this time I'm not gonna sketch the graph and I'm not gonna to calculate algebraically anything. I'll just ask you, and you can answer the question by your own. So our third example can be the equation x plus 3 in absolute value is equal 1, and the easiest way how to calculate this is to use the technical explanation. So what would you say about this equation in manner of distance? You try it by your own, and then I'll explain or tell you the result. Yeah, so the answer says, or the term says, that the distance from, and now the question is from which number? And if you said from negative 3, you are right, is 1. Which means, and it is if and only if, and if you don't know how to calculate it in your head, then it's okay if you sketch the number line. Here is number negative 3, and you travel 1.1 unit to the right, so you will come to the negative 2, and then 1 unit to the left, and you will come to negative 4. So you can find out that the solution is if and only if x is equal to negative 4 or x is equal to negative 2. So the solution of this very simple absolute value equation is two-element set, numbers negative 4 and negative 2. You don't basically have to use a graphical method or algebraical method if you understand what's behind this equation. Okay, so this was like the first part of solving absolute value equations, let's say theory and with the explanation. And in the next video I'm gonna explain you a little bit more complicated equations, though as you will see they just look a little bit complicated, but the solution can be found very easily. So first, thanks for watching, and see you during our next video about how to solve absolute value equations. Bye bye.